but it relates to all the other lessons. It relates to 1, 2, and 3, and I think it relates most to lesson 6-3, and we just finished it. So what am I going to relate? I'll tell you in just a moment. Let's go ahead and draw a coordinate plane. And make it neat. Don't make it sloppy, please. I don't want it to be sloppy. And it doesn't have to be huge. It just has to be neat and a little bit of time put into it. And let's talk about this line right here. Go ahead and draw a few tick marks. I'm going to go with 5 on each axis direction. So 5 there. And as evenly spaced as you can get it. It doesn't have to be perfect, but sometimes you need to extend lines like I just did. Okay, so we got our coordinate plane there.
How many lines? 5 on each.
Or sorry, 5 in every direction. I'll do this because I'm going to draw a lot of these. I'm going to say it's a 5 by 5. It's technically a 5 by 5 by 5 by 5, or you can call it 10 by 10, but that's what I mean, 5 in every direction. Okay. Then I want you to put a couple points. I want you to put 1 point at 0, 1. So I'm not going to do that. I want you to try it out. Put a point at 0, 1 on that. So starting at the origin, where do you go?
To the right. Up. Wait, no. Up.
Yeah, 0, 1 means you don't go anywhere left or right because that's 0, but you go up 1. That's your point. And label it 0, 1. Hold on. We're going to keep doing this because, this is from a previous lesson, but we'll see if we can get it. All right, I need you to label another point. -3, -1. So put -3, -1 where it goes. -3, -1. So that should be right about there. I went 3 to the left, down 1, and then label it -3, -1 to make sure. All right, you guys good on that? Mm-hmm. Now I want you... This is where we're going to put 6-3. I want you to give me a best fit line for the 2 points.
Easy. Easy money.
Yes, this should be money here.
You want to bet?
No, not anymore, because they're like, please get a line.
It's like a perfect one.
I know, thank you. I use my ruler, the ruler I have. So if you have, look, here, some of you who struggle with the line, like here, I have Tucker, I have a binder. If it has a straight edge somewhere, I use it to just draw the line. My book can also dub as a line, so I can do that. Okay. Then I need you to do this, guys. I need you to put arrowheads on both sides. Arrowheads on both sides. What do the arrowheads tell me?
They go forever.
They go forever. They should match up in this way. Okay, but if they don't, make them match up. Okay, what kind of correlation is shown here?
Positive.
So your choices are positive, negative, no.
Positive.
Positive, and who can tell me why? Thomas?
Because your line is going up and your dots are going up.
Okay, from left to right, like a book, the line is going up. You always read left to right to know correlation. Positive.
But it has a
What if it's going left to right but down?
So it'd be a negative correlation. Yep. And we'll get some of those. Yes, sir?
It has a line going forever down also.
It does, right? But that's why I want you to read it from left to right. Because like you read it like a book, you're like, if you're reading it from right to left, that means it's so Mr. A, should we read it one or the other? Read it left to right. So it goes up. Okay. It's like if you're driving up this mountain, you're going that way, you're going to be going
That way.
up. Thank you. All right.
Is the Cherokee thing this weekend?
No. This is like in April.
Isn't it like for spring break?
You already have it?
After spring break.
Y'all already have it?
You're
I thought
gonna
it
be
was
gone.
during
No,
spring
Mr.
break.
Isn't this game gonna be ourselves?
I don't. Yeah, that's a long time. That's long. Okay, can we get to this? Because that's a long time.
I still take the gun.
All right. The slope of the line, and I want you to write this down. Slope is referring to steepness. Steepness. So when you hear slope, you're thinking how steep the line is. Now, some of you could describe it It's not super steep, but kind of steep. I mean, we can use words to describe it, but your words and my words may not match. You're thinking, that's super, like that's really steep, because I'm thinking about riding a bike. Some of you are thinking, that would be really steep if that's not that steep, if that's the roof of my house. So we have to be on the same page with our steepness description. So this is how we're going to describe it. We have to describe it numerically so that we're all on the same page. If I can give you a number, it's 5 steepness, the steepness of 5. And then you're like, that's a steepness of 6. Which one's more steep? The steepness of 6, right? We can compare that.
I know that.
Okay. Here we go. I want you to write this down. Rise over run. This is like critical key piece of info for this lesson for today and tomorrow. Yes, sir. Oh, no. Sorry. This is like the next point. So if that's confusing, just erase that. I'm fine with it.
My line is not straight.
Okay.
Yes, sir.
Is it like gradients or something?
Is it okay if my...
Sorry?
Is it gradients or something like
Yeah. You talk about the grade of something or gradient. That's the steepness of, and they use this info right here. Yep, that's it. Okay. This is going to be one of the hardest things I go through today. But I want you to practice it over and over again, and you will get better at it. Ma'am.
Your lines have to be completely straight.
No, but use a ruler if you can to make it straight. That would have been the line. Okay. And that's fine. You just get practice. Okay. I want you to write this. It's a little formula. The rise of the run equals, and the formula looks complicated, it's really not that hard to work with. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to say that a few times because people get really confused and like, what are you talking about?
Why is it the Y1 below?
Ooh, great question. Good question.
Why do you put a 1 if it's just
Another good question.
I don't know.
Can I answer those little by little? Okay, let's do this.
Because it's negative.
I want you to write rise over run equals y sub 2 minus y sub 1 and x sub 2 minus x sub 1. Let's just look at rise over run. Okay, when I'm looking at these 2 points, do you guys notice that because it's a positive relationship, the line is going up? But I want to know how much up it is going. So how far up is it going? So this is how I describe it. From this point to this point, how much did I actually go up? 1, 2. Would you guys agree I went up 2?
Yeah.
Okay, I went up 2. So I'm going to write a big fat 2 there to remind you we went up 2. Okay. Then from here to here, how much did I go to the right? 1, 2, 3. 3. Do you get that? I mean, do you understand what I'm doing? I'm jumping tick marks. I went 2 tick marks up, 3 tick marks over. The steepness of this particular line is equal to 2 over 3. That's the steepness. That's it. Yeah, well, let me show you why.
Yeah, I don't like that.
And how do you know if you
I like those 2 at the top.
But as soon I'm going to describe how we figured that out. Watch, I'll show you. Ready? I'll show you guys. I'll show you. Now, let's say Mr. A's graph was awful. Like my tick marks were like evenly spaced. I can't even find out how many times I went up or left to right. Watch this. The ordered pairs told me all this without me having to draw little jumps. Okay, look at this number right here. -1, right? Everyone looking at this number?
Yes.
All right, what's the difference between -1 and +1? What's the difference? 2, right? How do you go from -1 to +1? You add. Look at -3 and 0. What's the difference?
Positive 3. You gotta add 3.
But if it was positive 3, would it be negative?
Don't you have to subtract 3 from 0 to get to -3, so it wouldn't be negative?
What?
Wait. I lost you when you said "don't you."
That's like
No.
checking your answer, right?
Yeah, you can check your answer that way.
So that's not me.
Okay, but listen. I'm so excited about this. If you guys can listen and get it even today, it'd be awesome if you could figure this out. Mr. A, I'm tired of you saying left to right. Because why can't you look at it from right to left? You can.
No.
Shh, quiet. Okay, ready? I'm going to start from this point and then go over. I'm going to go from this point and go over to this point. Ready? How far did I go down? 1. So 1, 2. Are you guys okay with that? Yeah. I went down 2. So down 2 we're going to call negative 2. Like you went down 2. You guys okay with that? Please be okay. Okay. And then I went over to the left. 1, 2, 3. Which going to the left usually means negative 3. Oh, those numbers are so bad. Are they?
Yeah. Just negative 2 over negative 3. That equals a positive.
No. You cannot just tell me, Mr. A, that it makes sense either way. You can't say that.
Smart math lesson you was saying. Math is just confusing that way.
No, the thing is this. When you are coming up, listen, when you are coming up with the slope, just look at from left to right and think, all right, that's positive, right? You can just say positive. But the numbers will always tell you the same thing. It's not negative, but positive. And you're like, oh, but Mr. A, it's 2 negatives. What are 2 negatives divided by each other going to get me?
Positive.
A positive. So that slope is not going to be negative unless I did something wrong or different, which is not correct, right? It's going to be positive. This also equals positive 2/3, okay? Either way.
How do you know which one goes on top of the bottom? It's just whichever one you do first.
Okay, great question. The change in elevation, just like the grades and gradients, the way they measure it is always the vertical change, so how much you go up or down, over how much you change left or right. So how much did I change from here to go up? 1, 2. So that's going to be my top number. How much did I change right or left?
3.
1, 2, 3. So that's going to be my bond number, and that's the description. And you're like, wait, but that didn't work. Okay, how much did I change going up or down? I went down 2, and then I went to the left, 1, 2, 3, negative 3, which still equals positive 2/3, because numbers always work. Not because Mr. A said so. Not because this book writes that. Oh, cool, it does write that. Because there's somebody who came up with this before I found it out. Let's look at the author. Who is the... Okay. Before the author. Oh, who did he learn from? Oh, from his teacher in some school. It all has to go back. Aristotle figured some of these things out, and he learned it from somebody, and they learned it from... And it all goes back to the Lord. He put these things there. We just describe them. Okay, let's do another one. Let's start again. Another graph.
I like this.
I love this.
Oh, gosh. It's your job.
No, it really isn't. Listen, I love history. When we had, Jeremiah, we went to school together, and he used to do the sports broadcasting. Jeremiah yeah. And so I would see him on TV. He's giving like updates on the school sports. I'm like, oh, cool. And then now he's speaking to you guys. I'm like, oh, that's cool. But listen, that made me want to study Black history. I want to study the Civil Rights Movement. I want to see what did Dr. Martin Luther King say, how did people respond, and how people are still doing the same thing today. Good and bad. So it's still there. We haven't solved that problem. But I love history, and it's not my job to love history.
Did y'all play basketball together?
No, I don't think. No.
Is he good at this one?
I don't know. No.
I know, Mr. Upster is Flash.
Just make this. I think you could just make this a 4x4. I did one on 3, but I'll just go here and extend it out. 4x4. 4x8. 8x8. Okay, Abby, I want you to put a dot and tell me where to go. -3, +1. So where do I go? -3, +1.
Sorry, that way.
Left or right?
Left.
1, 2, 3.
Down 1. Sorry.
That's okay. -3, +1.
Oh, up 1. I'm sorry.
That's okay. label it -3, +1. And Avery, give me another point. 3, -1. So where do I go from there?
3 to the right. Down 1.
Okay, so that's 3, -1. Now notice, aren't they the same digits but different signs? So they're different spots. They're not the same point. All right, go ahead and connect them with the line. So here's what do your best on that, Chloe, because
Every time he goes up, the other one goes down.
ooh,
False.
positive relationship, negative relationship, or no correlation?
I don't know.
Negative relationship, because left to right it goes
Down.
All right, so we get that. That's 6-3. That's what I really wanted you to get. Okay, now what I want us to do is we're going to describe how steep. We're not going to just say, yeah, it kind of goes downward, or some of you are thinking, no, it goes downward a lot. No, it's kind of in the mean. No, it doesn't go down at all. We can't describe it that way. We have to describe it mathematically. So this is what we're going to do. All right, look at this point. To go from this point to that point, how much do I go up or down?
You go down 2.
1, 2. Which would be described how? -2. Very nice. You guys know how to describe that. Going down 2 is -2. And then which way do I go? Right. How many times? 1, 2, 3, 4, 5, 6. That's positive or negative? Positive 6. I'm emphasizing the positive 6. Now, did you have to... Listen, how many of you, it took you a while to draw this out? Okay, that's fine. How many of you don't like this?
Not me.
You actually do like it.
No, we don't.
Goal number, what is it? That's number 33. Oh, man. 60. I'm almost there. You like this more than you think. Okay, let's keep going. What would the rise in this description, in this slope be?
It would be -2/6.
Good. Sorry, the rise is -2. What is the run?
6.
What can that reduce to?
-1/3.
No. Yeah, thankfully it'd be nice. -1/3. Now, was it a positive relationship or negative relationship? Negative.
I get that. 7 -1.
So if it's just a negative relationship, then it's going to be negative on there.
It has to be a negative slope. Please don't forget that, because on someone's test or quiz, someone's going to put this. They're going to get the right numbers. They're going to get 1/3, and they're going to put positive. It must be positive, Mr. A. It can't be positive because it's going down. Yeah, okay.
How do you get 1/3?
Okay, but here, let's look at it, guys. Please stay with me. I want to help you out. If you went from left to right, you get -1/3. But what about going from right to left? Let's see here. How much would I go up this time? 1, 2. So that's a positive 2. This does not look good for me already.
-6.
And then I go over to the left. 1, 2, 3, 4, 5, 6, which would be described as -6. That's totally opposite. That's 2 over -6, which still reduces to...
-1/3.
Okay. We're not done yet. I've already told you this, and I think if you took I'll tell you this anyway. Do you guys remember taking a quiz? And do you remember how the first problem had a negative sign? Anyone remember? And someone asked me, Mr. A, is that negative sign for the numerator or the denominator? And what was my answer? Close. It's for one or the other or the whole thing. Ready? One or the other or the whole thing.
Why is it not just the whole thing?
Well, you can make it any one. Any one will work because they're all the same. In that problem, you can say the whole thing. In this problem, it's easier to do it one or the other because then you're gonna have to find the slope. Because if I said no sign, you're just picking 6 and 2. You're like, wait, but what's the number? I don't know. It's better to do one or the other because one's positive, one's negative. But it depends on the problem. Yep.
So looking at like a -2 and a -6, what is these in there?
A -2 and a -6, what would that give me? Positive 1/3, which means the line should not have been going like this. It should have been going like that. If that's the case, if you got those numbers, because that's a positive slope. Okay. What if and don't react yet, but just think in your mind. What if I told you that you have to graph every single one of these problems, all 10 of them? It'd be rough. It would be rough.
Okay, Roger, stop lying here.
Wait, do we?
No.
How was like
On the last problem, Ellie, what were the 2 points we started off with?
-3 and 1, and then 3 and -1.
Okay. So I would say, graph these on a coordinate plane, draw the line, the best fit line, which is a perfect line, and then give me the slope. No, you don't have to do that because of your formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You're like, wait, that doesn't do anything. Here's what I want. Yeah, you're looking at the coordinates now. Look at me. Look at me, guys. I'm making your life easier, not harder. Because this problem you can do on the graph, and I think most of you be successful on it. But imagine if I just increased it -13, 23, -10.
Wait, hold on.
Now you're having to graph that on a number line. You're going way out here, way down here, and then like,
You subtract your y coordinates and then x coordinates, and it comes as a fraction.
sorry, I'm still doing the problem. Oh, I miscounted. Ugh.
Savage Mr. Ed.
I don't know. So this is what you do. You use a formula. Okay, look at these two ordered pairs. What's the x value in the first ordered pair?
-3.
What's the y value?
1.
Isn't it in this format? X and y? Okay. What's the x value here?
33.
The y value?
-1.
Someone asked me, Mr. A, why do you put a 2 and a 1 down there? How many x values are you dealing with?
2.
2. Somebody said, Nelson, what's x? Nelson should be thinking, which one? Because which one am I talking about?
The x value.
Both of them.
Yeah. -3.
Both of them? I said, what is x?
X.
Not what are x's. It's -3 or 3. Ready? Ready? I'm going to give you another chance, Nelson.
Oh, I know. The first thing.
What is x sub 2? What's x sub 2?
X.
X squared.
What's x sub 2? What number represents x sub 2?
Is so many.
3. What number represents x sub 1?
-3.
What number represents y sub 2?
-1.
What represents y sub 1?
1.
The reason we use these subscripts, we call these subscripts, is because you're talking about two y's and two. Do you guys, do any of your home bases have someone with the same name?
Yeah, Gracie and Gracie.
Okay, Gracie and Gracie. So you say Gracie and Gracie, Gracie, and I'm talking about Gracie Smith. And Gracie, I'm talking about Gracie Holmes. What do? We give them, and some people do. You could say it different ways, but we usually say. And I remember growing up, Gracie S, Gracie H, right? X1, X2. Are they still X's? Yeah, but one is 1 and one is 2. So you separate them somehow.
So the first set of numbers is 1 and the second is 2.
Yeah, and that's just, I hope you could switch them, but that makes sense to us the most. And you're like, okay, what's going on? What's going on between these two numbers? They're being
Subtracted.
ready? What's -1 minus 1? What's -1 minus 1? -2. You guys get that? What's 3 minus -3? Be careful with that. 3 minus -3.
Positive 6. Positive.
What's -2 over 6?
1/3. -3.
I don't need a graph. I don't need a graph. You don't need a graph because you have the
That
formula. You like the formula. And if you're like, Mr. A,
I just don't.
yeah, maybe my classmates, those common folk, like the formula, but I like just drawing it out. look on your workbook and go to page. I'm going to just show you what your homework's going to be, and that's sad. Page 181. Thank you. 181.
This is so confusing. Is it going to get hard on Justin?
It does. Oh, Swivel. Swivel doesn't like this. I never said Swivel had to like this. I just said you had to like it. Okay, but anyway, go to page 181. And I would ask you to do number 24.
Like right now?
No. I would ask you to do number 24, and you have to graph it. Okay, some of you could get it. I have no doubt you could get it. It's not that bad. But some of you are going to get tripped up with all those have steps that you have to deal with.
Whenever -1.
So what the answer to that? What would the answer to that be?
Let's go.
Okay, you would get a little bit tripped up, but if you use the formula, all you're doing is you're subtracting the x's and subtracting the y's, you get the answer.
Is the answer -1?
No, it's 1 over -1.
Which one is the x to the second?
What's the answer, though? That's not the answer. The final answer would be
X over 1.
-1.
-1. That's the final answer.
Oh yeah. Wait.
But I'm not making you do that one yet. We're going to do that later. Okay, let me give you a problem here, guys. Do number 2 on page 181. Do number 2. All I'm going to do is I'm going to write those points, -3, 7, and 4, -5. You got to be super careful, because if you're not careful, you're going to get the right maybe number with an incorrect sign, or you get the correct sign, different numbers. They're not the same. If I had 2 points on a coordinate plane, I want you to describe the slope. And you're like, how do you do that? You use a formula, which is this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Notice which variables are in the top, always. Y's. Which ones are on the bottom? X's. You don't switch them. But Mr. A, I thought x comes first. On an ordered pair they do, but not in our formula. Because we're talking about what? Rise over run, which is slope. Okay. What's the difference between -5 and what's the difference between -5 and 7? Well, what's -5? Sorry.
How do you know which one's y sub 2 and y sub
Great question. Is this x and that's y? And is that x? Well, no, you got to tell me that. You got to be able to tell me that. How many of you can tell me if that's x and y?
How do we know?
Because they're always in the x and y format. They're always like that. They have to be like that. But now what you're determining is that which ones are sub 1, sub 2. Ready?
The first one's sub 1. The second one's sub 2.
Okay.
Wait, but then how do you know which one's like rise and
Oh, that makes so much sense.
Well, the rise is always dealing with the y's. You can even memorize that. Y's, rise. Oh, look at that. I never thought of that. X's run. Okay, I don't know. Okay, what's y sub 2 out of these numbers? What's y sub 2, Olivia? Shh. What's y sub 2 out of those? -5. That's how we get that -5. What's y sub 1, Jack?
7.
7. What do you do with those two? Subtracting. What's -5 minus 7?
-8.
It should be -12.
Right. Wait, why? How?
Just because -5 minus 7. Okay. What is x sub 2, Gracie? What's x sub 2?
4.
4. Good, positive 4. What's x sub 1, Daniel? -3. What's happening between those two? They're being subtracted. You cannot forget that negative sign. It's not 4 minus 3, it's 4 minus -3, which is really 4 plus 3, which is really just
7.
So what is the slope? -12 over 7. Leave it like that. That's it. -12 over 7. That's the slope. Somebody tell me, without putting the points on the graph and drawing a line, does the graph do this? Does the graph do this? Or does the graph do that? It has to do this.
Because it's a line.
It goes downward. It goes down.
Don't draw this out. I'm just going to show you why that's true. -3, 7 would be like up here. 4, -5 would be down here. Is that true? Buzzer beater. Yes. Is that true? Sorry. Is that negative?
Wait, are they always going to be
Yes, always subtracted. Always, always, always. But what is 4 minus negative 3?
Yeah.
4 plus 3, which yes. Yep, but it's always subtracted. Yes. It's going to be going down from left to right. Be gone, my class. Wait. Oh, you want to see it? Yes. Bye-bye, Swivel.